Hello everyone. Today we are going to discuss about series connection, parallel connection, and current, how it is dividing in the circuit, and also voltage, how it is dividing. We'll take with few numerical examples. We'll see how these are happening. Okay, so then first we'll see the series connection. In the last video also I have explained about the connection. So if the elements are connected in series, so total value or equivalent value of the resistance is equivalent to sum of the individual resistances. For example, if I are taking this the circuit, all the resistors are connected in series, R1, R2 and so on. Here R equivalent, how to find out, that is equivalent to sum of the R. That is known fact. How it is, just you see here, total input value of voltage is V input, V in of t. Okay, total current it is IN of t. Already we know that if the elements are connected in series, current is same, right, in the entire circuit. Now, if you want to find out R equivalent for this circuit, so V input by I input is equivalent to R equivalent, right? So that is the way you need to find out R equivalent. Now, so V equivalent, that is a V input is equal to I input into R1 plus I input plus into R2. So input means in, right? So plus and so on IN into R, right? Now we want to find out only R equivalent. R equivalent what? Vn by In. So that is equivalent to R1 plus R2 plus R3 plus and so on. If you want to mention in conductance, it is only reciprocal, right? So R equivalent equal to 1 over G equivalent. But generally, if elements are connected in series, if you want to find out equivalent or total value, summation of the resistors, it is easy. If the resistors are connected in parallel, at that time, if you want to find out total, then you take the conductance. That is the best way of finding the equivalent values. Okay. Now, how the voltage is dividing in the same circuit. For the same circuit, all elements are connected in series. Because here current is same, voltage is dividing. So how it is? V in equal to V1 plus V2 plus and so on Vn, right? So what is V1? Current is same, In into R1. What is V2? In into R1, right? If you want to find out individual voltages, because V1 it is voltage across R1. So V1 equal to In into R. What is In? So that is the value, right? V in by R equivalent. What is R equivalent? Sum of the all the resistors. That is V1 equal to Vi by Vin by In. Okay. So that is which one? Vi by that. So you will get R equivalent only. So if you want to find out Vi by R equivalent, you will get only the In into R1. Okay, R1 into Vin by R equivalent R1 plus R2 plus and so on is. In general, if you are taking Vg of t, J equal to, for example, 1, V1, right? So that is equal to R1 by all the values, sum of the all, that is a total R equivalent, R1 by R equivalent into V. Why you are taking R1 into V in by R equivalent. If you want V2, suppose voltage across R2, so V2 equal to R2 into V input, again it is the same, V in by R equivalent. If you want last one, so voltage across Rn, so Vn equal to Rn into V in by R equivalent. Now, in this way, voltage is divided, but current is same because all are connected in series. Similarly, we'll see the parallel circuit, and in that voltage is same. Already we know that because those parallel branches are connected between only two same nodes, right? So now we will see here. So equivalent conductance of the resistors connected in parallel is sum of their individual conductances. Already we know, last video I have explained about this one. Now here voltage is same. You see here two nodes are there here. So all the values of resistors R1, R2 all are connected between these two nodes only. Okay, voltage is same but the current is dividing. IN equal to I1 plus I2 plus and so on IN. Okay, how it is we'll see here. Now voltage is same here. We want to find out current. Total current is equal to here. What is the value? IN. Right? IN equal to I1 plus I2 plus and so on. Okay. What is IN? V in by R equivalent. Right? V by R is nothing but that is only Ohm's law. V equal to IN. V in by R equivalent. That is equal to. So I1. What is I1? V in voltage is same. V in by R1 plus V in by R2 plus and so on. V in by R1. So Vn is common. Vn is common. You can cancel out. The remaining value is 1 over R equivalent equal to 1 over R1 plus 1 over R2 plus 1 over and so on 1 over R. Right? So because this one, if two elements are there, it is easy. You can use direct formula and you can find out because first two elements only it will be there if two are connected. Now if number of elements are more, then in place of this use the conductance because 1 over R1 it is nothing but G1. So 1 over R2 G. At that time it is like summation. So 1 over R equivalent G equivalent equal to G1 plus G2 plus and so on Gn. It is like summation. That's why we are using always parallelly connected elements. At that time, if you want to find out total value, you can use conductance. Okay. But here, voltage is same, current is dividing. Right? How to find out those currents? We'll see here in this. That is, in general, Ij of t. Okay, j equal to 1, 2 and so on. Okay. So that is equal to Gj. We are taking in terms of conductance. Gj by G1 plus G2. That is the total value of that G equivalent into I n. Okay, that is the value. Now, same way if you see this one, if Ij equal to 1, I1. I1 equal to what? G1 by R equivalent. Sorry, G equivalent into I n. So G1 is nothing but what? 1 over R1 by 1 over R equivalent into I n. So 1 over R1 by 1 over R equivalent. That is equal to what? R equivalent by R1 into I n. Okay, you see that. IN is that is the total value of current. So here you are taking first one we are finding, but it is coming down, right? R equivalent by R. Okay, that is we'll see with it. We'll take two elements are connected and parallel. That is a special case. So we'll see how we can find out I1 and I2 value in a simple manner. Okay, this is. Now you see here, it is a special case. Two elements, that is the two resistors are connected in parallel. So between A and between node B, two nodes. Supply voltage is V, total current is I. So current is dividing here. One is I1, another one is I. Already we know. So voltage is same for the parallel branches. So V equal to I1 R1 and V equal to I2 R. Right? So this one, this because parallel branches. So from this we can find out what is I1, V by R1. What is I2, V by R. So what is the total current? I equal to I1 plus I2. Substitute these values in this. Just you see blue lines here. Substitute the value here. Total current I1 plus I2. What is I1? Already we know on the left side. V by R1 plus V by R2. So let it be outside 1 over R1 plus 1 over R. That is equal to V over R equivalent. What is R equivalent? Again same thing, that one in the bracket whatever the value you have, that is right. 1 over R equivalent equal to 1 over R1 plus 1 over R2. So what is R equivalent? R1 R2 by R1 plus R, right? So that is the value here. Now that is the equivalent value. Now you want to find out only I1. How to find out? So V by R1. V by R1. What is the V? R equivalent into I, right? That is the value. R equivalent into I. So now what is R equivalent? R1 R2 by R1 plus R2. This is the value, right? R1 R2 by R1 plus R2 into I. This from this expression you see, into I into 1 over R1. That is a formula, right? That is I, V by I, V by R. Here R is R1, right? So what is the V here? R equivalent into I. R equivalent is nothing but R1 R2 by R1 plus R2 into I into 1 over R. R1 R1 cancel, the remaining is this one. So that means this current, first current, you can say I1, it is in terms of total current, that is equal to R2 by R1 plus R2 into I2. Similarly, you can find out I2. That is also what? It is a reverse. Again same thing only. V by R2. What is V again? R equivalent into I. R1 into R2 by R1 plus R2 into I into 1 over R2. R2 R2 cancelled, remaining is R1 by R1 plus R2 into I. Okay. So in this way you have to find the values of currents. Here current is dividing. In this way you have to find it. Another simple thing here while finding. So just observe the figure. You can, so in fingertips you can remember how to find out without writing or just you see here. If you want to find out first value of current I1 in the first branch, just to see total current into second value of resistance R2 by total value of resistance R1 plus R. Similarly, if you want to find out the current I2, so at that time total current I into opposite value, right? So that is R1 by R1 plus R. In this way you can find out easily, you can remember. Okay, that is. Now we will see in the following circuit, find the R equivalent. First you find out R equivalent value. Now you see, when you are finding R equivalent value, instead of going left to right, just start from the right. Okay, it is easy to find the final value. Now you see here at the last branches, 4 ohms, 5 ohms, 3 ohms, all are connected in series, right? So if these three are connected in series, so that is the summation only, right? 4 plus 5 plus 3, all are ohms only. 9, 4 plus 5, 9, 9 plus 3, 12. And that value, it is parallel with 4, right? 4 parallel with the 12. So what is the value? 4 into 12 by 4 plus 12, 48 by 12. How much? Okay, 48 by 16, 4 plus 12. So how much it is? Total value is 3. Now this 3, it is in series with the another 3. So both are series connected. If both are connected in series, how much value it is? Again 3 plus 3 is 6. This 6 value is parallel with another 6. 6 and 6 both are in parallel. So 6 into 6 by 6 plus 6. How much? 36 by 12. How much will you get? Okay, so entire this, it is a value of 3. Now you need to find out R equivalent, that is equal to 2 ohms plus what is the value of this entire 3. 2 plus 3 5 plus 1 6. That is the value of resistance, that is a total value, or you can say equivalent value of this. In this way you have to find out. Okay. Now we will see another one with the voltage and currents. In the following circuit, find the current values I1, I2 and I3, and also voltage values VA and in the given circuit. Okay, now you see already mentioned representations, also directions, because current always is in directions and voltage they are showing in polarities, positive and negative polarity. Here also, so all are resistors only. Start from right side. So you see 3 and 3 both are connected in series again. Okay, just I have given a rough hint only. Just it is for your understanding purpose. Okay, you need to write in elaborative way and step by step process. Now you see 3 kilo ohms and 3 kilo ohms are connected in series. So total value of that it is 6, right? So then that 6 and this 6 kilo ohms both are connected in parallel. So 6 into 6 by 6 plus 6. So how much will get? 3 ohms. That is 3 kilo ohms. Okay, and then 9 kilo ohms and 3 kilo ohms, equivalent value of that. 9 plus 3, 12 kilo ohms, because these two are connected in series. Total is 12 kilo ohms. Now we want to find out total value of current, that is I1, right? So how to find out voltage by R equivalent? What is R equivalent here? 12 kilo ohms. 12 by 12 kilo ohms. How much it is? 1 kilo. 1 million, because kilo, that is a 10 power 3. If you are writing in numerator, you will get here 10 power minus 3. So total value of current, it is I1 equal to 1 milliamps, right? So now here it is a current is dividing. I1 is equal to I2 plus I3, right? So current is dividing. That principle you have to use. If you want to find out I2, how to find out total current I1, that is a 1 milliamps, multiplied by opposite value of resistance, that is both are connected in series, right? 3 plus 3, 6 by 6 plus 6, 12. So 1 milliamps into 6 by 12. How much will be? Because all are the same units only. Okay, so 6 by 12 means 1 by 2 into 1 milliamps, that is a 0.5 milliamperes. That is the value of which one? Similarly, you can see I3, that is also same. Here 6 again, it is a total current is I1 into opposite value of resistance, 6 kilo ohms by 6 kilo ohms plus 3 kilo ohms plus 3 kilo ohms. What is the total value of resistance? Again you will get 0.5 milliamperes. You can check here, because I1 equal to I2 plus I3. 0.5 plus 0.5 is 1 milliamp. Got I1, right? So in this way you have to find out current. That is a current diffusion principle. Now how to find out voltage VA and VB? VA is voltage across 6 kilo ohms. VB is voltage across 3 kilo ohms. So already we know I2 and I3. So if count VA, what is VA? I2 into that particular resistance 6 kilo ohms. 6 kilo ohms into I2, 0.5 milliamperes. Kilo milli cancelled out. So 6 into 0.5. So that is 3 ohms, right? So if you want to VB, again it is current, it is flowing I3. So I3 into 3 kilo ohms. I3 is 0.5, 0.5 milliamperes into 3 kilo. Milli kilo cancelled, 3 into 0.5. So 1.5 ohms. Okay. In this way, how to find out that. Okay. Now this one I will give hint. Please try. Okay. So find out the value of resistance. Again, it is a equivalent resistance only. Like first example what we did similar way find out. From the right side we start. We see here 1 and 2, 1 kilo ohm, 2 kilo ohm, both are in series. So add that one 3, again 3 and 6 are parallel. You find out. After finding that 10 and this value are connected in series, again that value is parallel with 6 again. So in this way from right to left you calculate and find out the value of resistance between nodes A and B. Okay, that is for your practice. Now you see here in this following circuit find the current. Now here it is not series or both are mixed here, right? So you see here 12 volt source voltage, it is connected in series with the 20 ohms resistor, and 3 resistors 30 ohms resistors are connected in parallel in series with the 20 ohms resistor, and that is again connected in series with the 10 ohms resistor, right? In this way the circuit is there. Now we want to find out the total value of current here. How to find out? You know already 30 ohms, 30 ohms, 30 ohms. All three are connected in parallel. You know how to find out R equivalent. You can say 1 by R equivalent equal to 1 over 30 plus 1 plus 1 by 30 plus 1 by 30. Okay. So you can find out R equivalent value. Then all are connected in series. 20 plus this equivalent plus 10. Total equivalent, total value is you will get R, right? So voltage by resistance is nothing but current. That is a ohms law. Followed by whatever the value you are getting. In that way you can find out that. Okay. So you can find out the value of current. Okay. In the next video, I will explain the importance of another law in addition to the Ohm's law. In addition to the Ohm's law. Okay, thank you.